For the following circuit, use the mesh current method to find the unknown mesh currents. So the first thing we're going to do is label the clockwise currents for the three meshes, I1, I2, and I3. Then we're going to write the KVL equation for mesh 1 as 4I1 plus J4 times I1 minus I2, which equals 15. The KVL equation for mesh 2 is negative J times I3 minus I2 plus J4 times I2 minus I1 plus 20 with an angle of 60 degrees, which equals 0. And I3 is equal to negative 5 with an angle of 15 degrees because it is clockwise and the current is flowing counterclockwise. So when we solve for I1 is equal to 1.237 minus J 3.75 amps, 3.95 with an angle of negative 72 degrees, and 3.95 e to the negative J 1.25 amps for all the three forms that we can state a phasor. I2 is negative 2.514 minus J 1.238 amps, 2.8 with an angle of negative 154 degrees, and 2.8 e to the negative J 2.68 amps. Example 4. Use the node voltage method to solve for the unknown node voltages in the following circuit. Once again, we have a supernode at 50 with an angle of 45 degrees, and we have nodes V1, V2, and V3. So we are going to have KVL and KCL at the supernode. So V1 minus V2 equals 50 with an angle of 45 degrees, which is the KVL equation for the supernode, and V1 over 10 plus V2 over J50 plus V2 minus V1 over negative J5 plus 5Vx equals 5 with an angle of 60 degrees, which is the KCL equation at the supernode. And next we're going to have a constraint equation, Vx equals V3 minus V2 for the dependent source. And then we're going to have a KCL equation at V3, which is V3 minus V2 over negative J5 equals 10 angle 30 degrees plus 5Vx. So then we use our calculator to solve the simultaneous system of equations, and we get that V1 is equal to 143.8 with an angle of 47.3 degrees, or 97.5 plus J105.68 volts. V2 is equal to 93.9 with an angle of 48.5 degrees, which is equal to 62.22 plus J70.33 volts. And V3 is equal to 91.97 with an angle of 48.9 degrees, which equals 60.46 plus J69.31 volts. And Vx is equal to V3 minus V2, which equals negative 1.76 minus J 1.02 volts, which equals 2 e to the negative J 2.62 in radians. Or in polar form angle notation, 2.03 with an angle of negative 150 degrees. Example 5. Use the mesh current method to solve the following circuit. What you should observe by now is that we're solving the same circuits using both methods so that you can see it doesn't really matter. You can get the same answer. Sometimes one method is easier than the other, but it still works. So here we have I1 is equal to 5 with an angle of 60 degrees. I3 is equal to negative 10 with an angle of 30 degrees. I4 is equal to 5Vx. Next, we write the KVL equation for mesh 2 as 10 times I2 minus I1 plus 50 with an angle of 45 degrees plus J5 times I2 minus I3 equals 0. The constraint equation is Vx equals negative J5 times I4 minus I3. And when we solve the system of equations, we get that I2 is equal to negative 7.25 minus J 6.24 amps, which is equal to 9.57 with an angle of negative 139 degrees, or 9.57 e to the negative J 2.43 amps.